Yes. Good morning. Today we are going to discuss load test on single phase induction motor. Okay. So what you are seeing right now is the nameplate of your single phase induction motor. Okay. So in this nameplate detail you have various parameters related to the particular motor. So the manufacturer will give these details. Once they manufacture, they will give all the details and they will dispatch to us. Now what we are going to do, we are going to do some experiment based on this specification. Okay, come to the tool, we will check one by one. So this is the overall view of your motor. So in your home you have seen tiny amount the size of motors in your house. So this is the one of the single phase induction motor available in our machines lab. Okay. So what is this? This may be new to you. This is called brake drum. This is called brake drum. It is made up of aluminium. Okay. So it is like a one rotating wheel. It is connected in the driven end of your motor. So always motor having two ends. One is the non-driven end. One is the non-driven end. That means in this end we didn't connected any load. Here you see this is a shaft output. Here we are going to load. How we are going to give the load? It is not the actual setup in our real life. Okay. Whenever you come to the lab session, we won't give you the actual load. Instead of that, conventionally we will use this brake drum loading method. What is this brake drum loading method? Very simple. If you make the motor to start rotate, it freely rotates. There is no load at all. How to give the load? Very simple. If I rotate this knob, please observe the knob as well as the belt tension. Now the belt tension is totally free. If I make this knob to rotate, you observe only the belt tension. What happens? It giving some restriction to our rotation of motor. Now see, now I am unable to rotate it very freely because we have little amount of load. So this is called brake drum arrangement. Okay. So using this, we are going to give the load. Okay, what are the setup required to conduct this experiment? We will see one by one. Okay, before that, this is a single phase induction motor. We are going to do load test in this particular motor. Okay, so this is our induction motor. In that, we are going to do the load test. So the nameplate detail what we have shown earlier may not be visible to you very clearly. Now you can see them same nameplate detail available in this chart. Okay, what is this? So the name of the motor is single phase induction motor. So in our theory classes we have discussed what is single phase induction motor. Now we are skipping all the theory portions. We are going to concentrate only in the experimental setup. Okay, in detail what are all things available? Please observe. What is kW? Kilowatt hour. That means the power rating of the motor is 1.5 kilowatt. But what is this HP? From the school days itself we have studied the HP is nothing but horsepower. So always the motors, electrical motors and mechanical engines are specified with the help of the parameter or the unit is called horsepower. Okay, HP. So here the power of the motor is 1.5 kilowatt, HP is 2 HP. Okay, then what is the voltage I can apply to the motor? So I can apply either 220 volt or 230. How? Which one decides this? The name of the motor, please see. Single phase induction motor. Therefore we are going to apply 220 volt or 230. That's all. Then RPM, revolution per minute. Since it is here the output is a mechanical output. Once you give the electric energy, it will start rotate. What is the output you are observing? Only the revolution. So what is the unit of that? Revolution per minute is equal to 1440. Is it the motor rotates 1440 all the time? No. If you apply the load, there will be a slight reduction in the speed that we are going to observe today. Okay. Then what else? What are the remaining things? Ampere. What is this Ampere? So always the nameplate detail. In the nameplate detail, if I want to give very clearly, the volt is nothing but a rated voltage. The RPM is nothing but a no load speed. Then what about that Ampere? It is the full load current. It is 16 Ampere. Then watts 1500. So here they are given as a 1 kilowatt. The same thing is given detailing in terms of watts. Supply frequency we know well. Our Indian frequency is 50 Hz. Then rating, insulation, these and all we will discuss in the later session. Okay. Now you slowly. Yes. So far we have seen what is our single phase induction motor and its nameplate details, and what is brake drum loading method we have seen little bit. Now straight away we will get into the circuit diagram. Okay, so this is our actual circuit diagram. So you may aware of these symbols. Okay, I think you can name what are the things available here. So here this is the input terminals. Then this is what? DPST switch. Then this is your auto transformer. Then AC voltmeter, AC ammeter, wattmeter. Then this whole setup, the whole setup is your single phase induction motor. Then what is this one? This is not an electrical component. This is our mechanical component, that is our brake drum. Then two spring balancers are mounted in the mechanical support. See there, the same setup we have drawn here. Okay, I think it is clear to you. Okay, now you may aware of all these things, but we will look at once. See, very first one. What is the first one? DPST switch. See here, this is our power board. We have some terminals over there. Can you see these terminals? Now we will explain you what about these terminals, and we will match with our circuit diagram. Okay, so what we will do, first we will start with the input terminal. Okay, so before that we will do one thing. We will identify the components and we will identify the individual terminals in the instruments as well as the motor setup. Then we will go to our connection one by one. Okay, yes, we come to here. What is this? Very well you know, this is your auto transformer. Okay, this is our single phase auto transformer. Okay, how many terminals are there? 4 terminals. What is the purpose of this 4? 2 is for input, 2 is for output. Then auto transfer, what is the function? We will give the input supply across these 2 terminals. Then based on this knob position we will get the output. Okay, then so 4 terminals in the auto transformer. Soon we are going to connect, please wait. Then come to this guy. Who's this? V means voltmeter. Okay, this is our AC voltmeter. Look into the terminals. How many terminals are there? 2 terminals. Okay, 2 terminals. Then come to this. What is this? Ammeter. A represent what? Ampere. Okay, so the ammeter, again I have 2 terminals. Okay, then who's this? W. Somewhere we have seen, no, in our name radius also we have observed the same thing. Yes, W, watt, power. So in this experiment we are going to measure the voltage, current, also we are going to measure the power. But for wattmeter have many terminals. You no need to afraid. In your engineering practice laboratory itself, you are familiarized with these terminals. But anyhow, we'll reference this in a very short note. See, we no need to bother about these many terminals. Go to your symbol straight away. We will focus on only the 4 terminals. What are all these 4 terminals? M, L, C and V. What is that? M, L, C and V. Where is the 4 terminal really available? Come here. This is my M. Yes, 3 terminals, M, L and C. Okay. So here you observe. Please observe. Here this is M, L, C. Where is V? See here. Here you have 3 voltage levels. So we need to choose which voltage range we are going to use. Okay. So in our case, the input rated voltage, as we discussed, we are going to use 230 volt. So which one I can choose? I can choose either 300 or 600. But I never use 150 because it is lesser than the quantity what you are going to measure. So let me put it in 300. So M, L, C and this is your V. In our experiment, this 300 is your V. Okay. Then this coil setups and all you know well. We will cover this one in detail in the separate video. Now, as far this connection is concerned, using this wattmeter, you can select the current rating. Okay. At present, we have chosen the 20 ampere rating. That and all we will cover in the later session. Okay. Now you come here. So this is your ammeter, 2 terminal, common and 20 ampere. Okay. Then here voltmeter, common and 300 volt. These are all very simple. If you come to symbol also, you have 2 terminals. Okay. But you may ask why you didn't mention the terminal over here. Because these terminals are reversible. You can connect it at any way. But usually what we will do, the common terminal in your voltmeter, usually we will connect it in the lower potential, that is your neutral line. Okay. Then the other terminal, what you have seen just now is a 300 volt. So we are going to connect our voltmeter across these 2 terminals. Then similarly, in the ammeter, common and 20 ampere. So common always we will connect it in the input terminal, in which the current enters into the meter, and the V20 is the terminal in which the current leaves. Okay. Come to the circuit diagram. This is the entering terminal. Let me mark it as a common. Here I can make it as a 20. So these and all you no need to write in your observation and record. Just for understanding, I am including these 4 terminal notations. Okay. Now come to the circuit diagram. This is our whole setup. Now we are going to make the circuit setup. As usual, we have some connecting wires. These wires are not like your electronics laboratory wires. Here the current rating, you know, it is 20 ampere. So the diameter of the wire is little high. Okay. So this specification and all we will see. At present it is, please make a note of it. It is 2.5 square mm wire. It is 2.5 square mm wire. You have a multi-colors. So usually for phase we try to use red color. For neutral we will try to use black color. In between we will use other colors also. Okay. Yes. Come back to our circuit diagram. First terminal is phase and neutral. Where it is available? See here. This is your phase. This is your neutral. But here we have one more additional component in this workbench. It is this fellow. This is your starter. DOL starter. Okay. So what is the purpose of this starter? The name itself gives that to start the motor we are going to use. Can you observe 2 buttons over here? 2 buttons. One is dark green, another one is the red color, but it may looks like a dark brown. Okay, green for start, the red for stop. That's all, very simple. This is start button, this is stop button. So this test bench is designed in such a way that the input single phase is available here. This is my DPST switch. This is my DPST switch. This is my DPST switch, but it is an rotary switch. It is a rotary switch. It is going to serve the same function. Okay. So if I turn on, it will give the power across these two terminals, phase and neutral. Okay. So what we are going to do, from the phase and neutral, we are going to give the input to our starter. Then once I make the starter to on, the starter will produce the output across these two terminals. So without giving much introduction, we will start this connection by one by one. Come here. So ensure the power is in off condition. So with the off condition, we are going to start give the connection. Very first one, from phase to the input terminal of my starter. Then what is the next connection? Yes, very good. Neutral. From neutral, we are going to connect it to the neutral input terminal of my DOL starter. So successfully we gave the input supply to the starter. Then we are going to take the output from the starter. It is very simple. There it is simply it is given as a P out and N out. What is P out? Yes, it is phase. So this output, now we are going to connect it to our input of the auto transformer. So in our diagram, you won't find the DOL starter. Please ignore that. Simply you consider only these two terminal. So P out and N out. From the P out, we need to connect it to the one end of the input terminal of my auto transformer. Then what is N out? N out I need to connect it to the again another end of the input terminal of my auto transformer. So phase neutral, come here. Where is the input terminals? These two are my input terminal. Can you identify the color, please? Yes. Again, this dark brown or red indicates the phase and this black color indicates the neutral. Similarly, observe in the output, here also we followed the same color indication. This is for phase, this is for neutral. Okay, now you come here. I need to take the output from the P out and the other end, this red color. Can you observe? This is some pair of wire. Don't get confused. I am going to use red for phase, blue for neutral. So the other end of the P out wire, I am going to connect in the input terminal of the auto transformer. That's all. Then the blue color wire, we are going to use it for the neutral output need to be connected to the input of my auto transformer. Is it okay? This connection is okay? P out to auto transformer input. That's all. Now where we need to start our wiring? We need to start our wiring from the output terminal of the transformer. That means these two terminals. Please closely watch. From these two terminals, one end I need to connect it to the one end of the ammeter as well as one end of my voltmeter. Shall we connect this setup? Yes. Now let me take one wire. Okay, this is called not a wire, it is called as a probe. Okay, these are all called as a probe. Okay, so I am going to take the probe from the output of the transformer to one end of the ammeter as well as the voltmeter. Now we will do one thing. We will connect this terminal to one end of the voltmeter. Then other end we will connect to the other end of the voltmeter. Then from there we will proceed our wiring. Okay, now we will finish this voltmeter wiring. Is it clear? Now I am going to connect the phase to where? Phase to where? Phase we need to connect it in 300 volt. Then neutral. Yes, very good. Neutral we need to connect it in common terminal of my voltmeter. Is it okay? See here. Neutral is connected to common. This is connected to the 300 volt terminal. That's all. Then remaining things are very simple. I need to take another wire. And I need to connect it in the 300 terminal to my ammeter. Okay, no need to go back here. We already have connected up to this. So we can start from here to here. So 300 to common terminal in the ammeter. That's all. Then please closely watch your circuit diagram. From the other end of the ammeter, that is your 20 ampere terminal. From the 20 ampere terminal, we need to connect it to where? We need to connect it to the M. This is the M terminal in your wattmeter. M, L, C and V. Okay, M. So where is M and C? Already we have discussed. This is my M terminal. So I am going to give the input to M terminal. Is it clear up to this? Then what is the other end of the current coil? This is your L. So this is your current coil, this is your pressure coil. That and all you know well. Okay, we will start from L. So where is L? Yes, very good. L is available in your wattmeter. This is your L. From the L, where we need to connect? L to M1. Where is M1? This is the M1. What is M1 represents? That is your motor terminal. It is a single phase induction motor. It has only two terminals. One is for the phase, another one is for the neutral. So we are going to connect it in the phase terminal. That is your M1. So almost we have finished our circuit. What are all things left? Go back here. What are all things we left? We have finished this line. Voltmeter is over. Ammeter is over. Up to M over. What all things pending? M to C common. Here you need to connect on loop wire. Where is that? Take on loop wire. Connect M and C. See here one thing is that these probes having one hole here. So if you want to take, you want to tap the power from the same terminal, you can insert it like this. Can you observe like this? So what happens? This terminal, this wire and this, all the three formed one node. This is one common point. Okay, very simple. Then the other end of the wire I am going to connect to the C. Successfully we made the MC loop. That's all. Only one connection is pending here. What is that? What is the only one connection? That is my V2 M2 terminal. V2 this neutral terminal. So V2 neutral terminal where I can connect. So this is my V. As we discussed already, here we are going to use this 300 as a V terminal. 300 as a V terminal. So this V is this 300. Okay, so let me connect it here. Where we can connect this V? Check it. It is going to the neutral terminal. Where the neutral is available? Is it I need to go up to auto transformer? No need. The terminal is available in the one end of my voltmeter. Check where is your voltmeter. This is your voltmeter. This is your voltmeter. Where is the common point? See, this is your common point. I can connect it either here or here. Any two way I can do it. We will connect it here. Yes. So successfully we have finished all the connections. You may ask, who will give these connections? Who will give these connections? Don't worry. Come to the motor for a moment. See here. Actually we left one small connection. The M2 terminal we didn't connect. So the M2 where we need to connect, M2 we need to connect it in the same neutral point. So now we got the neutral up to here, up to 300 we got. Okay, so we will proceed from here. Is it okay? So neutral we have connected, then we will see where is these connections. So for the purpose we have removed the new terminal box in your motor. Please find these connections are already permanently given. Okay, only these two wires are taken into output. These two are phase and neutral input wire for the particular motor. These two terminals only named it as M1 and M2 in our test bench. M1 and M2 terminals are these two. If I give a single phase supply, automatically motor will get start. Yes. Without making much time, we will start the experiment. Before starting any experiment in our machines lab, you need to take few precautions. Point number one. Before giving the connection itself, I forgot to tell my power should be in off condition. Please observe the switch. It is in off condition. Then my auto transformer must be in a zero position. That means what? In case if we forget to make this switch off, due to the initial position of this auto transformer, it will produce only zero output. Double safety. Okay, then what else? The motor should be in the unload condition. It is in the unload condition, we have checked already. So after giving the connection, what you have to do, you need to verify once. So we already verified, therefore we are going to start. What is the starting procedure? Very first one, we need to give the power to the board. Already we gave the power. Now we need to make this DPST switch to close. So that is this switch we are going to close. Then here we didn't mention the DOL starter, but we are having the DOL starter there. So procedure number one, I need to make the switch to on. Now we made the switch to on. Okay, then we need to start the starter. How to start the starter? There are two colors. Can you tell me which button we need to press? Yes, we need to press the green button. Let me press the green button. And please observe the sound. The coil inside will get energized. Can you observe the sound? Let me make it off and ensure you to listen the sound once again. I hope you can hear the sound. Okay, now let me make it on. That's all. Come to here. Come. Observe. Voltmeter 0, ammeter 0, wattmeter 0. Why? We gave the input. What is the reason? Yes, very good. Our auto transformer is in initial position. It will supply only 0 volt. How to get the rated voltage? This is our rotating knob. I need to gradually increase the knob. So here we are going to adjust the knob. What is your task? Please observe the position of the knob as well as the deflection in your voltmeter and the remaining meters. Remaining meters you leave it. Observe only these two. The very first step, we need to adjust the auto transformer knob and we need to set it to the rated voltage of the motor. What is the rated voltage? 230 volt is the rated voltage. So here I need to make the pointer to move up to this. Closely observe. Yes, gradually it increases. Yes. Now, can you observe the reading? What is the rated voltage? Yes, it is 220, 230. Perfect. So we set the input voltage as a 230 volt exactly. Now you observe my knob is moved from this 0 position to somewhere You no need to memorize these and all. You please observe here. I need to make the knob to rotate up to this deflection. Hereafter, we should not disturb the position of our auto transformer. We can start do the experiments. What is our experiment? Now our motor is rotating. Before going into the motor section, please observe these deflections. My ammeter showing some current. Okay, very good. My wattmeter also showing some reading. Okay, come to the motor section. Observe. Yes. Now my motor is rotating. Okay. Now you can observe the rotation in the shaft. Okay. So this condition. So this condition is called no load. No load condition. Please observe the spring balance readings. This is my S1 and this is my S2 that we will tell you. Please make a note of it. This is S1 and this is S2. Spring balance reading 1 and reading 2. Now since no load, it deflects with the reading of 0, 0. Okay. Now what we will do? We will take one reading in the no load condition. What are all the readings we need to take? We need to, since we are going to do the load test on this particular experiment, I need to observe few electrical parameters. What are all the electrical parameters? What are all the electrical parameters we need to note down? Input voltage VL, then load current in ampere, then power consumed by the motor using the wattmeter. So here you may ask why we have a 2 column. Wait for some time. We will note down the reading in the observed column. Then we will tell you why I need to convert this thing with some multiplication factor. These things you have already studied in your engineering practice laboratory. But time being, please note down, you have one constant factor. With the constant factor, you need to multiply the observed value. Then you will get the actual power consumed by your induction motor. Okay, now come here. First reading, serial number 1. We need to note down the input voltage. What is our input voltage? It is exactly 230 volt. So note down the first reading as 230 volt. Then what is the current? Please observe how much it is. So here this see, you know what is moving coil and moving iron and all. This is your moving iron instrument. Okay, the scales are not uniform. Initially it is cramped, then later session it is little wider. Okay, that and all we will not discussing much here. So here what is the main thing? Here it is 0. After some time it is marked as a 2. Then after some time the long scale indicates 4. So 4 minus 2 ampere is divided into 10 divisions. It is like your rule scale what you have used in your school days and in nowadays. Okay, so that means 4 minus 2 is a 2 ampere interval between these two. It is divided with 10 divisions. So the least value is how much? It is 0.2. Please observe 2.5. Then the small divisions are up to 4 it deflects. So that means what? 4, this is middle value 3, then 3.2, 3.4, 3.6, then 3.8. Exactly it is 3.8 ampere. Note it down in your second table column. Okay, then what is the power? Power you check it. So here no load power you can't mark it perfectly because 0 to 100 there is no division. Okay, so what we can do, it is little greater than the 50. So let we take it as a 70. If we take it as a observed power as 70. This calculation part we will leave it now. So if you want to clarify what for this, let me do it for the single calculation. 70 into this multiplication factor, how much? 2. That is how much? 140. So as I told you already, we have noted down few electrical parameters. What is the mechanical parameter as per the motor is concerned? Come there. As per motor is concerned, what is the mechanical parameter we are going to measure? Please go through this chart. So these are all some mechanical parameters we are going to note down from, see this one you know, spring balance. So this is simple like your weighing scale. In that shops you may observe the same scale is used to measure your force, how much we are going to give. Okay, so S1 and S1 reading we can take it from this spring balance reading. Then what is this parameter? Speed. How to measure the speed? No surprise, this is the instrument called digital tachometer. Using this meter you can measure the rotation, okay, in terms of revolution per minute or meters per minute. Okay, but now we are going to measure only in the revolution per minute. Therefore make the slide switch to here, move it to right hand side. Now we are going to selected the RPM mode. Then what are the other things? Here you can find one rotating knob. In this knob we need to make it in contact with the rotating shaft. So this is a shaft. We need to insert the tachometer like this, but it didn't show any reading. So how to make the meter to on? Can you watch this push button? Now you please observe, if I press the push button, my system gets turned on. But it shows only rotary, it is not giving any reading. But if I make the shaft to rotate, it gives some RPM. Am I correct? So I can able to rotate only up to this much RPM. Now we will measure the shaft speed. So please observe, hold the button, then insert this meter, make the meter to touch with your rotating shaft. What is the reading? 1498 revolution per minute. Shall we note down this reading? Okay, now we got some stable reading. Okay, 1496 to 8, in between it fluctuates. We will make it as a round of value as, in between value as 1497. So our first reading 1497. This is the no load RPM. Okay, then observe the spring balance readings. Both the spring balancer shows the reading as 0. Why? Because it is in no load condition. Now what is the next step we need to do? We need to apply the load to the motor. How to apply the load? Gradually we need to rotate this knob, this wheel, thereby we will increase the belt tension. Okay, please observe the spring balance reading as well as the adjustment. So for now we are going to apply the load gradually. Can you observe the difference in sound? Yes, you can observe the difference in sound as well as the readings in your spring balance. Okay, so it fluctuates between somewhere. Okay, so we have increased the load. Previously in no load condition my ammeter shows 3.8. now it's slightly increased. We will increase up to 5 ampere, then we will take the corresponding readings in all the meters. Okay, so is it gradually increases? Yes, ammeter, I am increasing the tension. Also observe the reading in the ammeter, please. Ammeter, we will increase up to 5. Yes, now it's perfectly 5 ampere. Now what we need to do? We need to note down the current value first, 5 ampere. Then what about the input voltage? Please observe, there is a slight drop in the input voltage. Note down, it is showing in between 230 to 220. So exactly it shows 225 volt. 225 volt. We will discuss you why there is a 5 volt drop. That and all we will discuss later. Come back here. What is my wattmeter reading? It is not 70. It is increased up to how much? Near about 200. What is the exact value we need to check? So it is almost 190. 190. That's all. In the same way, again I need to increase the load. Here, what we need to do, electrical parameters we have note down. We need to note down the corresponding mechanical parameter. What are all the readings? RPM, then spring balance, S1 and S2 readings. Let me measure the speed first. Please observe. Now the RPM is slightly reduced. How much it is? 1468 to 70. Okay, let me keep it as a 1471. 1471. And what is the spring balance readings? S1 and S2. So this is my S1. So 0, 5 is divided with 5 small divisions. So 1 kg. Then this is 2 kg, 3, 4, 5. Now it oscillates between 1 to 2. So what is the exact value I can take? Let me take it as a 1.2 or 1.5. Let me take it as a 1.5 kg. What is the S2 reading? Observe. It oscillates between what? 5. Between 4 to 5 kg. So let me take it as a 4.5. That's all. Likewise, we need to repeat the procedure. Stop. That's all. So what we have done, we have increased the load gradually. The current get increased. In the same time, you observe the power. Power is also get increases gradually. So after taking these 3 readings, what we will do the calculation. In the calculation, multiply with the multiplier value and fill the actual column. Okay, so power observed, this is your actual. So we will take these readings only into our account. But these 2 readings are getting increases, but voltage, whenever you increase the load, there will be a slight drop in the input voltage. This theory we will discuss later. Now we will go to the mechanical parameter. What we have got, see, my spring balance reading is gradually increased, similar to our current and power. So this is the indication of increase in the mechanical load. What is the corresponding speed? At no load, 1497, but gradually it is getting reduced. This characteristics very much similar to our input voltage. Am I correct? So the voltage drop occurs. At the same time, there is a decrease in speed. So now what we need to do, using these readings, mechanical parameter and my electrical parameter, we need to do some certain calculation. Then we need to plot the electrical versus the mechanical characteristics. Electrical versus the mechanical characteristics. So this is the detailed tabular column what you will get in your observation and record. So here you need to note down these readings. Voltage is here, current is here, then speed there, then power observed and actual. So this is my observed value, this is my actual value. So speed already we have measured there. Then the spring balance readings S1 and S2. Once you finished this portion, the remaining things are calculation. This part we will discuss in the next video. Thank you very much.